Across the universe, gravity weaves a cosmic web, a vast network of galaxies, gas, and dark matter. For decades, scientists believed these structures were too enormous to rotate in any coherent way. But in late 2025, astronomers uncovered something extraordinary. A gigantic cosmic filament, tens of millions of light-years long, slowly spinning like a celestial tornado, not made of air, not made of clouds, but made of galaxies. To understand this discovery, we need to zoom out far beyond the Milky Way, far beyond our cosmic neighborhood. On the largest scales, the universe resembles a web. About 90% of galaxies lie along giant filaments, stretching tens or even hundreds of millions of light-years. These filaments form because dark matter collapses under gravity, pulling normal matter with it. Gas flows along these filaments like rivers feeding oceans, carrying material into galaxy clusters, the massive hubs of the cosmic web. But until recently, scientists believed these filaments were static. They didn't twist. They didn't rotate. They simply channeled matter. All of that is about to change. In December 2025, researchers using the Meerkat radio telescope in South Africa discovered a filament unlike anything seen before. A gigantic structure measuring roughly 50 million light-years long, containing over 280 galaxies. Inside this enormous structure lies a remarkable chain, a straight line of 14 hydrogen-rich galaxies, stretching 5.5 million light-years. What shocked astronomers wasn't the size, it was the motion. These galaxies appear to be aligned, their spins lined up, and the filament itself is slowly rotating at approximately 110 kilometers per second, about 245,000 miles per hour. This might be the largest rotating object ever observed in the universe. So, how do you spin something that big? To understand how a structure this massive could rotate, we need to go back to the early universe just after the Big Bang, when matter was still clumping under gravity. Galaxies get their spin from what scientists call tidal torque theory. Think of it like a cosmic nudge. As matter collapses, uneven gravitational forces twist it, giving birth to rotation. But this theory only explains spin on the scale of individual galaxies or dark matter halos. How do you spin a filament millions of light-years long? New simulations show that as gas and dark matter flow into a filament from multiple directions, they can create a twisting torque along its spine. Over billions of years, this slow, steady flow winds the structure like twisting a giant cosmic rope. This discovery suggests that the universe naturally generates spin at every scale, even at the largest known ones. But why is this discovery so shocking? Scientists long believed that spin alignment should break down over distance. Galaxies separated by millions of light-years shouldn't influence each other. Yet here, in this filament, their spins match. This implies that the cosmic web itself may determine how galaxies rotate, something never confirmed at this scale. It could also explain why spiral galaxies like the Milky Way have such consistent directions of rotation, a clue to their ancient origin stories. This structure also tells us something profound about dark matter. Dark matter makes up 85% of all matter in the universe, but it's invisible. We only detect it by its gravitational effects. This spinning filament strongly suggests that dark matter is not randomly distributed. Dark matter flows create angular momentum on enormous scales. These flows may be responsible for the shape and rotation of galaxies. If we can detect more spinning filaments, it could provide new proof for the existence and behavior of dark matter, something physicists have chased for decades. This changes how we think about galaxy formation, too. Galaxies don't form in isolation, they are born inside filaments. If filaments rotate, then a galaxy's spin may not be random at all. It may be inherited from the rotation of the larger structure. This discovery suggests that the cosmic web doesn't just feed galaxies, it shapes them. It may determine whether galaxies become spirals, ellipticals, or even fail to form stars at all. So what will happen to this filament in the future? Over the next tens of billions of years, it will continue spinning. Galaxies inside it may merge, collide, or fall into nearby clusters. Stars will form, then fade. Black holes will drift through the filament like cosmic anchors. As dark energy increases the expansion of the universe, this filament could eventually stretch, thin, and become isolated, a lonely strand in an ever-expanding cosmos. Now that we've found one spinning filament, astronomers are racing to find more. Upcoming surveys like the Square Kilometre Array and NASA's Roman telescope could map billions of galaxies, revealing the hidden motion of the cosmic web. We may soon learn that large-scale rotation is not a rarity, but a universal property of cosmic structure. A spinning structure larger than anything we've ever seen, a clue hidden inside the cosmic web, and a reminder that the universe still holds secrets beyond imagination. The cosmic tornado challenges everything we thought we knew about structure, formation, and motion in the cosmos, and it's only the beginning. Thanks for watching, and if you want to explore more deep space mysteries, be sure to subscribe.